Hi, my name is Jorge de la Vega, and I'm going to talk about the physical principles of lightning. Let's start. Okay, so let's talk about lightning. Lightning exists even before humans existed on Earth. As time passed by, early human civilizations incorporated lightning into their beliefs, where most of them were religious. Let's see an example. In Mexico, the Aztec civilization, dated from the 3 to the 600, called the Aztecs, had the god of the rain called Tlaloc, as seen in the image. But going back to the physical principles of lightning, let's talk about what is lightning. As said by the National Geographic, lightning is an electrical discharge caused by imbalances between storm clouds and the ground or within the clouds themselves. Most of this lightning occurs within the clouds. So, there are many types of lightning. Here I'm going to show you just 3 types. The most common one, which is ground-to-ground lightning. And here are another 2, which are intra-cloud and anvil crawlers. But then the question is, how lightning occurs? So, first of all, what occurs is charge separation. During thunderstorms, updrafts and downdrafts, which here we have an image of their description, occur very regularly. The updrafts contain small liquid droplets from the lower regions of the storm, and downdrafts transport hail and ice that come from the upper regions of the storm. So what happens when both of them meet? What happens is that water droplets release freeze and heat, and this makes graupel to be formed. So, when the graupel collides with water droplets and ice particles, what happens is a phenomenon that occurs, as said by the National Weather Service of the United States, which is that electrons are detached of the ascending particles and collect on the descending particles. So, electrons carry a negative charge, and the result is a top positively charged, as seen in both pictures, and a bottom negatively charged storm cloud. Okay, so the next step in finding how a lightning creates is field generation. I just thought about putting just an image because I'm going to explain it all with my words. So, field generation. As we have seen in class, positive and negative separates. So, obviously it happens the same here. When they start to separate, both positive and negative, an electric field is generated between the top and the base. So an electric field gets created in here. The separation of these charges into pools of positive and negative regions result in the strengthening of the electric field. So because these charges are separated into pools of positive and negative regions, the electric field gets very strong. As a matter of fact, the atmosphere is a very good insulator that inhibits electric flow. So just imagine, well, a very huge amount of charge has to be created in order to make a lightning. So when the strain of the electric field beats the atmosphere insulated properties, lightning happens. So just imagine the power that the electric field needs to produce in order just to beat the atmosphere insulated properties in order to make lightning. But lightning just doesn't end here, of course, because as you can see in the picture, we have another electric field created, which is here. You see? An electric field is also being created within the surface of the Earth, having below a negatively charged storm base, a positive charged storm base. So it is good to say that all these processes are invisible to the human eye. Then let's see how lightning develops between clouds and ground. As we saw before, here in image 1, the thunderstorm gathers another pool of positively charged particles in the ground level. Here shown. The differences in charges keep increasing, so positively charged particles rise up tall objects like trees, as shown in image 2. So all the positively charged particles go up the tree, and the other remain here on the ground. A channel of negatively charged, which is called stepped leader, descends from the bottom of the storm to the ground, as seen here in the image. This is called the step leader and starts to go down to the ground, where the positively charged is here, in the tree and on the ground. Then the step leader shoots to the ground in very quick steps. The time taken is less time than it takes to blink the eye. And as it approaches to the ground, the positive charge gets collected in the ground and in objects that contain it. In this case, the tree and the ground. So the positive charge passes through the negative charges and both create a channel called a streamer. When both channels connect, the resulting electrical transfer is what we see as lightning, as here. Common sites where lightning impacts are trees, skyscrapers, mountains, etc. because their top is closer to the base of the storm cloud. But it doesn't just mean that all tall structures will get impacted by lightning, but the probability gets increased. So then, a good question that I would like to introduce is how lightning rods work. So lightning rods were invented or created by Benjamin Franklin, as seen in the image with his famous experiment. And it's a pointed metal rod attached to the roof of a building. This is the pointed metal rod. This rod is connected to a big piece of copper or aluminum wire, which is connected to a conductive grid buried in the ground, as seen here. Here is a good example of how the lightning rod works. It's here, connected to a wire that is connected to the ground, to a rod that is inside the ground. What lightning rods do is that they provide a low resistance path to ground that can be used to conduct enormous electrical currents. Right? If a strike occurs and needs a lightning rod system, the system will have a very low resistance path and will receive a jump of the strike, which will divert the strike current to the ground. So that's the way lightning strikes work. Also a topic that is very common on persons when it's raining and persons are outside is about people getting killed by lightning strikes. So here we have an image of how to survive a lightning strike and the fatalities by state from 1959 to 2011. In the Washington Post, a leading expert on lightning injuries, called Dr. Mary Ann Cooper, says that 90% of people that are hit by lightning survives. Yes, 90%. But often with long-lasting neurological damage. Yes. A direct strike, which is like all people think strikes occur, is not very common. It doesn't happen very often. Of course, it can happen, but not very often. As well as contact strikes. The real danger of lightning is when it comes to a lightning strokes directly to the ground with more than 20,000 amperes of current. And it just doesn't disappear the current, of course not. It spreads out in the ground as a very dangerous and deadly current with its voltage decreasing with distance from where it hit. For example, a place where it's very dangerous to be is down a tree, as seen here. Just imagine if a strike hits here and you are in this part, probably you will be killed by a tree because the lightning will spread through the ground on a circle near the tree. So if a person is here, it's just going to be roasted. That's the most common type of lightning strike where people get killed. The second deadly kind of lightning strike is called side splash. And it's called side splash because lightning jumps from an object to a person, or it can also happen that lightning jumps from a person to another person. And this occurs because lightning follows the path with the least resistance to the electrical current to the ground. Thank you for your attention. I hope you understood almost everything I said. I hope so. Thank you very much, and I hope you like it. Well, one more thing. I made this video with Zoom. And yes, I'll leave you my references, my scientific references after I disappear. Thank you very much.